quick intro. My name is John Blackford. I'm working with Antiva, and I'm an engineering fellow. I wear a couple of different hats. I've also been attending Broadband Forum for over 20 years, I think, like 21, 22. It's good out there. But the different hats that I wear is I am a project leader for our OB USP agent project. So the OB in that stands for Open Broadband. Open Broadband is kind of the open source arm of Broadband Forum, so to speak. And the project in specific is about a USP agent, a reference implementation of a USP agent. So it's going to be based on the USB specification, and it's one of those projects that's been around for a little while. It's still in development. We're about to release our version 8 of the software, and it is out on GitHub for everyone to consume. Another one of the hats, as Jason just mentioned, I am also a work area director for the Broadband User Services with Jason, and I'm also chairman of the board of directors for Broadband Forum. And then one last hat that I have up here is for the Purple Foundation. I am a community board member on that group as well. So let's take you through services architecture, USP services architecture. But first, we're going to jump into a couple different industry trends. The first set of industry trends is really more from the vendor's perspective. What we're seeing is kind of a migration from proprietary stacks to more open source driven stacks. With your proprietary stacks, it's usually going to be tied to a specific CP vendor in their software. So it kind of locks in the solution where you have the CP vendor's hardware and their software, and there's not a lot of options there. You can certainly do some integration work, but what we're trying to move towards is more, kind of our goal is an open source driven stack that is hopefully a little more cost effective, where you can share the community, share the benefits of developing that software stack with the community itself, and opens up some freedoms to the service providers to how they choose which software stacks and software they have on their devices. The other trend we're kind of seeing is moving from monolithic device software to more of a modular device software. Monolithic has some inherent difficulties with it, that every time you change anything, you have to go through a long development process and test process. And it can take sometimes up to 18 months to get a release from, kind of approved with the service provider of what you want to do, to developed, to QA'd, to tested in the actual devices, to actually delivered into the field. And that's a long time. So as we move to modular device software, the goal is to, allow containerized applications that enable services and give us a better time to market on delivering software updates. So if we look at some industry trends a little bit differently here from a service provider perspective, we look at this first silo here. Basically, this is kind of where we have been for a long time, and we're kind of starting to move away from this. But your typical CP vendor, it picks the hardware that it's going to use. On top of that hardware, it puts its proprietary stack. Maybe it integrates an app or two. Those application integrations are not necessarily very easily. They can take anywhere for a couple months to 6 to 9 months to actually get accomplished. And the app vendor that you're working with is actively having to do this against multiple different CP vendors and multiple different hardware and chipsets and so forth. So it's a really a difficult situation for both the app vendor and the service provider who's just trying to get a new service out the door. So the next step in this evolution that we're seeing is kind of a start to move towards that open source device stack, where the CP vendor is still kind of responsible for the hardware and typically picking which open source stack it wants to use. But the service provider starts to have a little bit of a choice here, and that they can start to pick which services or which containerized applications they want to deploy on this. So instead of having those apps kind of integrated directly in to the CP vendor by the CP vendor and that app vendor, you now have a bit of a kind of containerized app that can get dropped into any of these open source stacks. And so it adds up a little bit more choice. And then the end kind of goal that I see that kind of industry heading toward is that you still have your hardware vendors, and now you have a choice of hardware vendors. And the service provider starts to bring in that open source device stack into his own decision process. So you can pick prpl OS on some things or RDK on others. And then there's a lot more possibility for containerized applications and also services. And this is kind of the end goal that I see a lot of service providers kind of heading towards, at least at the tier 1 level. Maybe they'll pick on in the tier 2s and tier 3s later. But it just gives them a lot more flexibility in what they can offer. All right. So in order for this to happen, there's definitely some things that need to change. And the reason why we're kind of looking at this point is that, the service providers are looking at all of this and it's saying, it's difficult to, provide new services at a quick and fast pace. And the reason for that is kind of that, a lot of what they have deployed right now is based on 20-year-old remote management designs and architecture, tier 69. Some of it's even older than that. If you look at some of the operators out there, they're using SNMP still. So that's way older than 20 years. But the goal of what we're trying to do here is to provide a faster time to market for those services, such that when that service provider or operator says, I need to provide a parental guidance or some kind of service to my subscribers, that they can do it within a matter of weeks to months instead of a year, 2 years. So there's definitely some friction points in the current solution that cause some difficulties, and this is where we'll start looking. First you'll have your remote management side of things. When you go to add, let's say in this case, a Wi-Fi management service, you may have to add new cloud components into your remote management solution, or you may have to provide some kind of cloud-to-cloud integration if you're talking about bringing in a third-party kind of Wi-Fi management solution. The second part is your gateway firmware. Obviously, if you're providing a new application for that Wi-Fi management, you may have to integrate software into your gateway. And doing this the old way could take up to 6 months to 9 months to actually do that integration sometimes. And then you have your, if you're in a Wi-Fi management solution, you also have typically some extenders that you're also dealing with. And if those are not the same manufacturer as your gateway, then you have to kind of have another little bit of friction there and trying to get those things to communicate with each other. And then the fourth piece is your smartphone or your application, because let's face it, everyone wants an app to do whatever they want in their house. You buy your Wi-Fi management solution from a retail provider, you're definitely getting an app that kind of shows you what's all connected to your network and everything. So that smartphone application may have to be kind of easily adaptable to bring in new kinds of services, whether that be a security option add-in or something of that nature. So how are we getting past this? What are the points that we're looking at to kind of make this an easier path? Well, first, we're bringing in containerized services and applications into your remote management solution. This gives you the ability to have that remote management solution be able to download new solutions down to the device without necessarily have to be able to update itself. Second, introduction of USP, both from a device management perspective, but also a software module management or lifecycle management perspective. Then you have number 3, your development of a services layer in your gateway stacks. This is the part of the software that sits on the gateway that allows it to download a containerized application and then run that containerized application. 4, since we're talking about Wi-Fi and the mesh aspects there, the Wi-Fi Alliance came and created the Easy Mesh solution that gives a standard way of communicating between that gateway and that mesh product or that Wi-Fi extender, such that you don't have to have the same vendor between those two. They have a standard way of communicating. And then the last piece, of course, is your smartphone application, where you would need to have some kind of dynamic capabilities to quickly introduce new UI features or maybe unlock new UI features or something of that nature. So that's kind of a look at things from a high level. Next, what we're going to do is we're going to drill down a little bit to look at some more details of what Broadband Forum has done, as well as a little bit of Purple Foundation to help make this solution a reality. First bullet point is there's obviously the device 2 data model, which we've been talking about all morning. That is a key ingredient to this. It is kind of foundation for a lot of the things around software module management. Next up is USP itself and USP services architecture, which was something that was, USP is the protocol for remote management of the devices. The service architecture is what we've added to enable some of this, and I'll go into some details about that here in a minute. The next part is actually kind of a sub-part of the service architecture, but it's the Unix domain socket message transfer protocol, or IMTP. This is sometimes called an IMTP. The I is for internal, but more formally, it's called the Unix domain socket, or UDS MTP. This is what's going to enable internal communications within the device. Then we have the concept of USP controllers and agents actually being embedded inside the device in the form of what a USP broker and a USP service is. And then there's also some data model extensions via the USP services that were added in to kind of help expose all the details around this. And then the last kind of piece here is the Purple LCM aspect, which is one of the options for containerized based services that live inside the device software. It's the piece that allows you to install applications and services and to run those applications and services. So looking at the right-hand side a little bit here, I'm going to dive in a little bit more. So this agent piece right here, and this controller piece in the cloud, those are the two components that existed before. If you go back and look at USP 1.0, USP 1.1, 1.2, those are the concepts that existed at the time. Basically, you have your controller that could live in the cloud. It could actually live in other places, but it's typically remote from the device, and it talks to a USP agent that's on the device. Basic concepts around USP. What we've done is we've added some concepts with the services architecture approach that allow us to actually embed agents and controllers inside of the device. And in doing that, we needed to extend the USP solution to offer something that was a little more efficient at communications from a message transfer protocol. So we didn't necessarily want to use STOMP or MQTT or WebSockets internally of the device. We wanted something a little bit more lean, like Unix domain sockets. So what we have here in this example is, let's say you have USP service. First, let me back up. So our USP agent is now going to be promoted into what we call a USP broker. And that USP broker is simply, it still has the agent on it. That agent can be used for communications outside of the device, but it also has a controller embedded in it. And that controller inside of it allows it to talk to agents inside the device. And then we have a USP service that can be added. Now that USP service has kind of at least one specific thing that it's going to do. It's going to expose some kind of data model. And that's what this green little piece here is. When that USP service exposes that data model, it's going to send a message from its agent to the USP broker's controller that says, this is the part of the data model that I'm responsible for. And I want you to expose this to the rest of the world. And that broker is now responsible for any controller that comes into it to say, okay, if you're asking for that part of the data model, I need to go delegate that over to that USP service. So you can have multiple of these USP services on the device now. They can all kind of be responsible for their own little parts of the data model. A USP service can also have a controller in it, as the example down at the bottom right here, the USP service 2. So the difference between USP service 1 and 2 is that USP service 1 really just has one thing it's doing. He says, I have a data model, I know what I'm doing, and I'm going to expose my data model. USP service 2 is a little more intelligent, where he has a little bit more responsibilities. He's saying, not only do I have a data model and I want you to expose that, but I also have the need to talk to other parts of the system. So I'm going to have a controller as well. And that controller lets him talk to the USP broker and ask for other parts of the data model, or potentially set other parts of the data model, do other concepts that, you know, are then going to be kind of taken from that broker and pushed off to other parts of the data model, whether they be in other USP services or just in the broker itself. And then the LCM piece on the top is really, that's the part that supports the software module management, commands, the install of a deployment unit or an application or a service, as well as updating it and deleting it or removing it. And that's all tied in back into the USP broker and the data model, such that all of this can work together in unison. Okay, so that's a lot of words and just a small picture. So what I would like to do is kind of step you through a little bit of what that means in a different way of looking at it. And so if you look at this picture, you basically have your gateway or your device, and it has a tier 369 or a USP agent on it. The USP agent has a data model, and it has the ability to communicate downwards to the rest of the system in whatever platform environment, you know, drivers and so forth. It communicates up to your USP controller, which, you know, can basically, you know, it knows whatever data model is going to be there. Maybe it does some cloud storage of different concepts as related to what that USP controller is trying to do as far as use cases go. But this is your basic intro. I mean, this is how you remotely manage a device without any kind of software module management. So as we start thinking about how do we extend that software module, how do we extend that device and maybe start looking at some modular software concepts. In this case, you know, this is an application that's integrated into the device, and maybe this is the old way of integrating that device because it's part of the firmware, so it's integrated as part of the actual CPE when it comes available. There's no software module management involved in this part yet. But this application makes it a little bit easier because it's using the IMTP, or the Unix Domain Socket MTP, for communications internally. So while it could have a third-party cloud communication, and maybe that's for some proprietary communication that it's doing, it also has the ability to expose its own data model to the USP agent, and thus expose its data model to the ACS, or the USP controller. Now you see at the top, as this new app came online, it exposed this blue portion of this data model. So it's showing that this app, as part of that firmware, has this, it owns or is responsible for that part of the data model. So next up, let's introduce the software module management concept. So in this case, the prpl LCM manager comes along, and it's now going to be responsible for installing new applications dynamically into the device, and dynamically, as those applications are installed or updated, new portions of the data model might become available. And so that's what this is right here. We have a containerized application. It also has an IMTP concept, so that it ties back in to the USP agent. And now all of a sudden, when that application comes online, your data model moves from the left-hand side there to the right-hand side, and you have a new piece of the data model exposed based on what that application is. And you can do multiple applications. Another one comes along, and it exposes another portion of the data model. And so that there's definitely a way that you keep extending and expanding your data model, and whether that be modularized software components that can individually be updated, like a DNS server or something of that nature, or it's applications and services that can be deployed that provide the subscriber with actually something that they can see and kind of touch and impact their daily lives. So that's basically where we are today. But there's definitely some next steps that are coming up. There's an evolution. The Broadband Forum is working on USP 1.4 right now. We're hoping to kind of get that out later this year. And some of the big concepts that we're working on there is around those applications and the authentication and the security involved in them. In USP 1.3, the IMTP or the UDS MTP basically says that there's no security or authentication done at that level. What we kind of decided earlier in this week, is that we're going to move that to be a TLS-based option. So we'll be able to provide a TLS security with authentication and certificates to now when an application comes online, we'll know exactly the way it is, which one it is. So one of the reasons we did that in 1.3 like that with no security is because we're very early days in this. There's not a lot of deployments with this out there yet. So the general concept right now is that any service provider that would come along and want to deploy a solution like this would basically say, I have a very curated set of applications I want to be able to offer my subscribers. And I know each and every one of those applications. I've tested each and every one of those applications. This is not an Apple Store or a Google Play. This is very curated. So not a lot of risk in those applications coming online and pretending to be something else or doing something weird. But we're looking at the future. So we're looking at, we need to make this a little bit more secure so that we can kind of evolve that a little bit. So maybe the service providers don't have to be as careful as before, that we can build some security into this. Another one of the big steps that we're doing is looking at a solution that kind of tells or controls which parts of the data model can be subscribed to by a service as it comes online, or can be registered by that device. That service. So the reason for that is that you can potentially see some applications may come online and start saying, well, I'm going to start grabbing all these parts of the data model. I don't really own them, but I'm just going to grab them and reserve them and just mess up the device's data model so that nobody else can use it right. We want to be able to protect against that. So again, 1.3 wasn't as important because we were considering more a curated set of apps, but as we continue to expand and evolve this solution, need a little bit more security in place, a little bit of way to kind of throttle things and make sure that they don't cause problems. And then if we look a little bit further down the line, another one of the things that we're looking at is, and you might have noticed this in the previous slides, each time you deploy a containerized application, the general thought right now is that each one of these applications would kind of have a little, jettison out to their private cloud portion or something like that. Maybe a little something that gives them a little special sauce. It gives them the ability to expose a few extra features or maybe gain a little extra insight by mining some data or something like that, maybe some fine-tuned controls that you can make. But as we keep adding applications on, this will surely become inefficient because every one of these applications could certainly have its own network link out of the device, out of the home, and into the cloud somewhere. So the goal would be to kind of take those away and turn those cloud applications or the cloud portion of the application into USP controllers. Because the applications are already exposing their data models via the USP agent, the broker. And you could potentially even use a single MQTT broker or something of that nature to limit it to one single connection out of the device instead of multiple connections. The one thing that I think really needs to happen before this can be a reality is that we have to be able to say when that application is installed, we have to be able to also say which USP controllers are allowed to access which parts of the data model. Because until that point happens, those applications might have portions of the data model they really only want exposed to themselves. And it may not have anything to do with what, the service provider's, quality of experience for the user or anything like that. It might just be some fine tuning that they need to do the application based on the environment that they're in. So that's, I think, one of the, that's not going to happen in 1.4, I don't think, but it is something I think we need to start considering after we get 1.4 out the door as one of the very next steps. And thank you.
Hello, Mircea from Bitdefender, Mircea Gliga. So I have a question in regards of running an application inside the container. So what would be the requirements inside the container for an application to be communicating with the controller of the broker on the host side? Do we need also OB USP agent inside the container? Do we also need the MQTT broker inside the container, or what
Right.
are?
Yeah, great question. You would not need MQTT. One of the points, one of the reasons, and let me go back to one of the slides here as I back up. All right. This USP IMTP, this is the UDS message transfer protocol. So you don't need MQTT. You would use the Unix domain sockets for that communication between your application and the broker. That can be done in a number of different ways. OBUSPA is in the process of being updated. It should be out later this month, the version 8, which will expose that ability to be embedded inside of a service. But there are also other solutions, as if you look inside prpl OS, Purple Foundation, that there are other solutions that also can embed that IMTP piece of code in other libraries such that they can communicate, so your application or your service can communicate to the actual broker.
Okay, so inside the container, I can talk only IMTP. It's sufficient to talk IMTP over the UDS with the broker outside.
Yeah, for data model, for data model things, exposing your data model to the rest of the environment, certainly. If you need to integrate with other parts of the system, you may have to utilize other technologies. It depends on what your application's doing and what APIs are available in the actual environment. Like if you're trying to access another part of the data model, you should be able to do that via IMTP. If you're trying to do that to like driver level where there's no other data model concepts, then not, because the IMTP is going to be talking to anything else that is kind of part of the device to data model that is exposed on the device.
Thank you.
Yeah.
Hi, this is Anil here. So when we said multiple apps can run on the platform, right? So, but the hardware could change based on the vendors, right? So do we have any abstraction layer below that? And then do we have any plugins, the hardware registers, or who's responsible for the plugins?
Yeah, so this is, if you look at this being built on the open source kind of middleware solutions like prpl OS and RDK, they all kind of have a lower layer or a kind of driver abstraction layer that they have in place so that you can basically have this piece of software that sits in between everything that's running on top of it and the lower layer drivers and the chipsets and so forth, and it abstracts everything away. That's typically part of that.
When there is a competing applications for the same hardware resource, so how does that is solved? Like, I mean, when let's say some application comes in and both the applications on the same hardware, is it exclusive or it is shared? So how does it get handled?
That's probably a question that's more applicable to someone in the prpl OS or the RDK. I think a lot of times they have that built into their what they call managers, like a cellular manager or a PON manager or something like that, something that's dealing with that layer directly and dealing with the drivers and the lower layer APIs, that they kind of build that into that software at that level. So it's something that would be built into one of the applications that is responsible for that, that's typically part of that operating system.
Since the northbound is standardized, would it be nice to standardize the southbound also, so that like, because there is where the multiple vendors are coming in, the way you northbound is standardized, probably some API level, that would really make it agnostic.
Yeah, I mean, the northbound, I guess, is kind of standardized due to what we've been doing in Broadband Forum so far, which is USP and the data model. The southbound or the lower layers, as I don't think we're quite there yet. I think that's kind of the intention of prpl OS and RDK, is to kind of help to standardize that. And I know that they do work together on certain topics. So I don't know, maybe that is definitely something, maybe it's something they're heading towards in the future.
I'd say the other thing to keep in mind from the perspective of this solution, even though John didn't go into like the real nitty gritty of how this works with what messages are sent and all that, but one of the things that happens is there is a concept of when an application comes online and says, this is my piece of the data model, it is now the owner of that piece of the data model. So if somebody else is like, no, I want to manage Wi-Fi, it's like, well, you know, I was first. But
Yeah, that I try to kind of show that in these different colored portions of the data model when they come online. You'll kind of notice that none of them are underneath each other. That's one of the things, and I guess I could have mentioned this as well. One of the things we're looking at doing is in 1.3, you can only register an object and everything. It basically, when you registered that object, you registered everything underneath that object. One of the things we're looking at in 1.4 is to be able to manage any piece of the data model. So it wouldn't just be a whole object. You could pick a single parameter here and there, a single data model command or an event. You can do a lot more flexible things with what we're planning for 1.4.
Tim, you still had your question? Or are you going to ask him afterwards? You don't want to make it an awkward conversation. We're all open here, Tim. Does anyone have any questions about sort of not necessarily the feasibility of this, but like, no, I mean, literally, right? Yeah. Or just sort of how far along this has come, because I know we have some answers in that. Like John was saying, a lot of this work is being done through some open source groups, which is a different way of standardizing things, but is more applicable to this level of granularity.
Yeah, I mean, yeah, OBUSPA, as I said, is a reference implementation of the USP spec from an agent perspective, has been working on this for a while now, and it's to the point where there is an integration with prpl for this. That integration is almost finalized. It should be in, I think it's prpl 3.1 is the version that will be all kind of wrapped up and available. And we've done some demos already. We've shown where we've, opened up or created a new service, installed that service, and had that service expose its own data model, and then done communications between services through the broker and all that kind of thing. So, sets, gets, adds, deletes, subscriptions. There's a lot that goes into being able to farm out and have that service own a portion of the data model such that everything that needs to go to it goes to it. So it's all kind of getting wrapped up, should be finished in the next couple of weeks, I think.
I have another question. What would we tell the application vendors that are out there about getting involved, and what sorts of things we need to hear from them, or stuff that they can help us help them?
Yeah, that's a great question. I think if you look at it from a Broadband Forum perspective, from a Broadband Forum, you're really looking at the software module management aspects. Are there things missing when you install or update an application? Things that are not in those commands that you may need access to. We've added a lot of things in the recent releases of the data model, things like host objects, environment variables, network access concepts. I think one of the next things we're adding is port mapping. No, we've added port maps. DNS, MDNS is one of the next things we're adding. So basically, when you install that application or you update that application, what are the things that we need to tell the system that you need access to as an application such that you can do your responsibilities? If you need to be able to, get access to a port mapping to do something, then we need to be able to tell the system that that application has that port mapping access. So I think that's, definitely a big thing for the Broadband Forum. If we can get that kind of information, you could also look at it from the prpl Foundation side of things. And in prpl Foundation, there's definitely an exercise underway to figure out how to expose libraries and APIs to those applications such that they can get access to the data that they need. Like potentially there's things not exposed in the data model that they need to get access to. I think that was one of the contributions we actually had into BBF this week around being able to kind of, snoop or packet inspect a little bit, such that, an application could look at all the different packets and figure out what they need to learn from those.
All right. Thank you, John.